In this video, we will talk about potential energy. Let's start with this example where we can see an archer shooting an arrow. At the beginning, as we can see in figure 1, the archer holds the string and the string is stretched. The arrow is at rest, thus its speed is 0. Once the archer releases the string, as we can see in figure 2, the string reverts to its initial shape and size, and the arrow is shot and is in motion. So at the beginning in figure 1, no energy is detected, but then in figure 2, we can say that the arrow has kinetic energy since it is in motion. We know that energy cannot be created or destroyed. It can only be changed from one form to another. Therefore, the kinetic energy of the arrow must have been converted from some hidden energy that was stored inside the string arrow system. That stored energy is called potential energy, and in this case, it is called elastic potential energy since it is due to the elasticity of the string. Note that potential energy is always associated with a system of two or more interacting objects. The elastic potential energy associated with a spring mass system when the spring is stretched or compressed by delta L is given by the formula PES equals half K delta L squared, where K is the spring constant and delta L is the change in length of the spring. For example, when the spring constant is 50 newtons per meter and the change in the length of the spring is 12 centimeters, the elastic potential energy is PES equals a half multiplied by 50 multiplied by 0.12 squared, since 12 centimeters equal 0.12 meter. This gives PES equals 0.36 joule. Now let's talk about another type of potential energy. In figure 1, the girl holds a ball. The ball is at rest, thus its speed is 0. Once the girl releases the ball, as we can see in figure 2, the ball falls under the action of its own weight and is in motion. Again, in figure 1, no energy is detected, but then in figure 2, we can say that the ball has acquired kinetic energy since it is in motion. The kinetic energy of the ball was converted from some hidden energy that was stored inside the system formed of the ball and the earth. That stored energy is called potential energy, and in this case, it is called gravitational potential energy since it is due to the gravitational interaction between the ball and the earth. The gravitational potential energy of a system formed of an object and the earth is given by the formula PEG equals plus or minus mgh, where m is the mass of the object, g is the acceleration of gravity, and h is the height of the center of mass of the object with respect to a certain arbitrary reference level for which the gravitational potential energy is set to 0. Note that the plus sign is used when the center of mass of the object is above the reference level, whereas the minus sign is used when the center of mass of the object is below the reference level. For example, a man of mass 80 kilograms, considered as a point mass, dives from rest from a diving board into an outdoor pool in a location where the acceleration of gravity is 9.8 meters per second squared. The water surface, taken as the reference level for the gravitational potential energy, is 23 meters below the diving board. The gravitational potential energy of the system man-Earth is given by PEG equals mgh and not minus mgh, since the center of mass of the man is above the reference level. We replace m, g, and h by their values, and we get PEG equals 1.8 times 10 to the 4 joules. And this is all for this video. Thank you for watching.